kind of talk about the plan for the week. It's a short week, remember? Did we know this? We're off Friday and Monday. Okay, so we are going to talk about, it's really the second half of our first lesson. We split it just because of testing stuff. We're going to talk about evaluating functions today. It's going to take a little bit longer than function or not because there's just a little more to it, but we can handle it, and then we'll finish up that 2.1 Delta Math today. I think it's maybe like 5 more problems. And then the next 2 classes are going to be about domain and range. So if you worked on that extension assignment in Desmos, it was kind of getting you started on the thinking of domain and range. This unit is more like conceptual stuff where the solving was like, you know, the nitty gritty, write it down, show your work, like calculation. This unit is more about like analyzing, looking at stuff, interpreting. So that may be good or bad news to you, but there's a lot of thinking that goes with those, but it's not so much like writing down on paper. So that extension assignment, if you haven't done it, maybe just try it if you've got some time, because I think it's good to kind of get your brain in that mindset of like what it means when we talk about domain and range. So we'll spend 2 days on it before we get to our Unit 2 test. But today we're about evaluating functions here. Let's look at, so last class we just did real quick, we talked about what it means to be a function. Remember, a function is a mathematical equation or inequality relating 2 variables in which the x value doesn't repeat. That's always the key. You're looking for repeating x's. So if you've got a table or a mapping, you're checking to make sure x's only go to one y. The y's we don't really care about. With graphs, we do the vertical line test. If the vertical line hits the graph twice, then that makes it not a function. So we talked about checking whether or not something was a function or not with all the representations. We did ordered pairs. We did discrete graphs. So that's a big part of your next part of your test is being able to determine if something is a function or not. And there's almost always like one question on the STAR test about that. So that should be an easy one. Okay, so evaluating, there's a little more calculation with this, so if you have your calculator out, because it's going to be your best friend for this, but we kind of need to talk about what it means. We got some vocab here, so we'll fill this in together, and then we'll just kind of jump into some examples. It's not like earth-shattering what we're doing, but again, we're showing work. Y'all know I want to see your work, so we're going to have to kind of write out what we're doing, then our calculator is going to take care of it for us. So, evaluating. We are on page 4. It says right here at the very bottom in the little dots, page 4. Evaluating is the process where you determine or calculate the output of a function when giving an input. Okay, so when I tell you to evaluate something, you're just calculating. You're telling me this equals whatever. Okay, it's not the same thing as solving. It's more just like plug it in and see what happens. I have to look at my cheat sheet. I'm not good at vocabulary. A input is the variable for which you're plugging in or replacing a value, most often the x or the independent variable. Okay? What do input and independent both start with? Page 4. I. Okay, so those kind of go together. Your input is your independent. Most often it's going to be your x, and that's what you're plugging in. Input, plug it in. Okay? An output is the variable for which you're solving for. Most often the y or the dependent. So that's how functions work. We put in an input. It spits out an output, okay? We put in an x, do whatever the function says, multiply it by 3, subtract 7, blah, 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 and then it's going to give us a y value that goes with it. So we're basically finding ordered pairs that go on each function, okay? Last little vocab section, function notation. Function notation is a way of representing a function so that both the input and output variables are clear to the evaluator. Function notation looks like this. I want you to look at how I wrote it, and then we're going to write it out in words next to it. So it's written F parentheses X. okay? That parentheses does not mean multiply here, not in function notation land, okay? You pronounce that, and you're going to see this notation all year long. You pronounce this f of x. So write that down so you know how to read that, f of x. F is just naming, hey, this is a function, we called it f. X is our inputs. X is our independent variable. We're going to be replacing x with certain numbers today, but I want you to kind of understand how to read that. It doesn't always have to be f of x. It could be g of x. It could be h of x. It's just a name, okay? But when you use this notation, you have to actually have a function. So if it's in this notation, you know the x values don't repeat. But f of x is the same exact thing as y. So f of x is the same as y. So typically, you've probably seen equations like this. Y equals 5x. Y equals x plus 7. Y equals x squared. You can rewrite these in function notation, and it's not changing the problem whatsoever. I just want y'all to get kind of used to that because I think it's easier to just write y equals blah, blah, blah. There's a y equals button on our calculator that we're going to use a lot. But function notation is a little bit more formal. The STAR test typically puts everything in function notation. So I don't want that to trip you up if you see versus if they are literally the same thing. F of x equals 5x. G of x equals x plus 7. H of x. The different letters on the outside, they're just different names because they're different guys. But we're all good here. Okay? Before we get into some examples, here's a little thing to kind of help you remember which one goes with which. And this will really help in the next couple lessons as well, is Dixie-Royd. So Dixie stands for your domain, which we're really going to harp on that next time. But we'll kind of start with that there. Your domain is talking about your inputs, aka your x values, or your independent variables. Domain, our inputs, your x values, your independence. It kind of just tells you, hey, these are all categorized together. Okay? Any ideas on what the R stands for? Range. Have y'all heard domain and range before?
Yeah. Yes.
Okay, good. So range is going to talk about your output, which is your y values, or your dependent. Good job. Your dependent variable. So this is just, again, you don't have to memorize this. You don't have to write on your test or anything. You just kind of keep the information straight. Because these words are all kind of interchangeable, and so we want to know which one is which. Okay? So we are not stressed out by the fact that this uses f of x function notation. Because what is f of x the same thing as? Y. Okay? It just tells us it's a function. When you're doing evaluating, I actually think it's a lot easier to use function notation because here's what's going on. Here's the type of problems that you're going to see. Okay, so put a little star by this. These are test questions, what you're going to see on your Delta Math. We're going to evaluate f of 7. Okay, what does that mean? We want to find out what is 7 inside of. Well, it's where the x usually is. It's inside of parentheses. So if we have an input of 7, what is our output? That's what we're finding. So let's say if the input, I'm just going to kind of write what we're doing just for this first one. If the input is 7, what is the output? Just so you understand like what we're actually doing. We're given an input, plug it in, get an output. Okay? So that's what we're looking for. So evaluate f of 7 for f of x equals 7 times x minus 3 plus 2. Okay? F of x, I'm going to underline the x and I'm going to underline an x right here. Whatever is in your input has to match what's in the equation. So what do y'all think we're going to do with this 7 right here? Where do you think we're going to put it? We're going to put it in where the inputs go, where the x is. Okay? So to show our work, here's what we're going to do. F of 7 is equal to, we're just going to follow the equation, but where we see an x, we're going to replace it with a 7. 7 parentheses, there's my x. I'm going to do a double parentheses there, and we'll see why in a minute. Minus 3 plus 2. So all I did was sub in a specific input right there. Did y'all do the double parentheses like I did?
Yes.
Okay, I really want you to always put that new input, wrap it in parentheses, especially when you type it. And then we're going to go to our calculator, and we are going to type this side of the equation, okay? There's no solving. F of 7 always has to stay there, so don't let that trip you up. This is what you're trying to find. When the input is 7, what's the output? So we can go to our calculator, and we can type 7, double parentheses, 7, minus 3, plus 2. Sometimes these can be really quick to type in. Sometimes they can take a little more work, especially if you got a lot of things going on.
How did you get 17?
That's not a 17. It's a parentheses
Oh.
around the 7. It's just not a very curvy parentheses.
I got a big number.
You got a big number? Big number. 30?
I got a negative 145.
Did you do a negative 3 or a minus 3?
Oh, I put negative 3.
Oh, it's got to be a minus. It's got to be a minus. Did you, anybody not get 30? Anybody not get 30? Hey, sit up. Did you type this? Okay, y'all have to do it. Y'all have to do it. You have to make sure you can type it correctly, because what if you get to your test and you learn, I don't know how to type it correctly? What's that going to be? Good or bad? It's probably going to be bad. Okay?
I got negative 145.
Did you do a negative 3 or a minus 3? This needs to be a minus 3 right there.
Oh, I did negative 3. Wait, so minus 3 and then.
Did you get 30?
Yeah.
So here's how you would write this, you guys. You would write
Oh, I see.
f of 7 is equal to
Minus 3.
30.
Wait, why do we have to?
About what this means. What does this tell us? When the x value is what? 7. The input is 7. What's the output? 30. That's giving you guys an ordered pair. I kind of want you to recognize that. That's telling you that the point 730 is in this function. It's on this graph. It will be in the table. I'm going to show you a way to check it. You want to see a cool way to check it? We understand we have to show our work when we do it, right?
Yes.
All right, let's go to our calculator. Have y'all used this y equals button before?
Yep.
Okay? Even though it says f of x, it is the same thing as y equals. So, up here, are you with me? Are you with me? All right, press it. Y equals.
Y equals.
Y equals. And we're going to type the function just as it is with an x in it, and we're going to check our value in the table. So I'm going to put 7 parentheses x minus 3 plus 2. This is my check. When I check, I always put the equation. The equation has an x. F of x is the same thing as y equals, so I just put the x is right here by the alpha.
Right next to the green button.
Right next to the green button. Thank you for
You
asking
could
that.
also just do alpha right here.
You could.
Yeah, I think this is a little
It's an
bit
extra
Then there's
faster.
green letters.
Okay.
It's an extra step.
Type alpha.
Okay. So does everyone have this typed in there?
Yep.
Braden, yes? Okay. Have y'all ever been to the table?
Yeah.
How do you get there?
Oh, you do.
Do you see the button that says table right here in blue?
I see graph.
Okay, what does it say right above it in blue?
Table.
Table, okay? Y'all find this button right here. This is going to be almost like probably your favorite thing you're going to learn all year is how to get to the table. Okay, do what? How'd you know? Okay, no other x's repeat. Okay, so right here, I want y'all to press second graph, and you should look at a table here. Now, here's what's great about the table. If you put a function in there, it's going to give you all the inputs, all the whole number inputs. And right next to it, where it says y1, is going to be the output that goes with each input. So if we want to check our work, where should we go? What input are we looking for on this problem? What input are we looking for? 7. So we're going to scroll to where x is 7, and boom, what's right next to it? 30. So did we do our problem right?
Yeah.
Yes. Okay? So I want you to show me your work by plugging it in and writing it out, but you can 100%, 1000% should go put this in your calculator and check it there. Okay? Let's try a couple more examples. Do y'all know how to get out of your table? Yes.
So,
You do quit and then you just press clear.
Second quit. Second mode. Yes.
if why can't you just use this to get the answer?
Because I want you to show your work.
Alright.
So I want you to write it out. You know I'm picky, but on the STAR test, is the STAR test going to care about your work?
Nope.
No. So I want you to show me what you're doing, and then I want you to use y equals to check it. Okay? All right. Let's look at this one. Find the output for the given input of 3 if f of x equals 13 minus negative x plus 2. Okay? All right. What's our given input here?
3.
3. So where are we going to put the 3?
Where the X is.
Where the x is. Okay, notice I put 2 because I want to write f of 3 on this side. So f of 3, we got to be careful with parentheses here because the way this is written down. 13 minus, open parentheses, negative, open parentheses again. And what are we putting in for x?
3.
Close, plus 2. Yep.
Wait, why do you have to do like double parentheses?
Anytime you replace an x, I want you putting that number in parentheses. Anytime.
So like put it in front basically.
Just like wrap that number in parentheses. You're going to be putting, and you can even kind of write it up here in your framework. Do you see what I did right here? Like I'm going to replace that number with parentheses around it no matter what. Okay?
This makes sense.
Now remember, just type this side in your calculator. 13 minus.
Like calculator work.
Right, like,
It is a lot of calculator
if
work.
you don't put the parentheses correctly, you'll get to the wrong answer. all the
I
time.
think you have to put a negative in front of the 3.
Yeah, so be careful.
Yeah, you
Just
have
like
to.
how I just
Press-
made those things.
So minus is, but after the 13, negative is in front of the parentheses there.
Just highlight, press enter,
What?
and then you can move it over.
Let's talk about this one. Okay, first thing. Look at this problem right here. F of x equals x minus 3 plus 2x minus 4. Do y'all see the first thing that I did? What did I do in blue? I put parentheses around the x's. How many x's do I have in this function? 2. So when I evaluate f of 9, how many places am I going to put 9? 2. And what am I going to put 9 inside of? Parentheses. Y'all don't overthink this, okay? You are literally just plugging in wherever you see an x, you are putting a number, but it's just important for simplification reasons that your calculator has that number in parentheses so that it follows the order of operations correctly. The calculator is doing the work for you. You just have to know how to type it in correctly. So f of 9, what's my input here? F of 9. 9. So I'm going to put it in. There's an x, so I'm opening up parentheses, subbing in a 9. Minus 3, no x there. Plus 2, there's an x, that's multiplying by 2. So I'm going to open up parentheses and sub in a 9. Minus 4. And all I have to do is put this right-hand side. Y'all see how I keep underlining the right-hand side? It's important you know you're only typing the right-hand side in. And your calculator is going to follow PEMDAS, and they are going to give you the output for when the input is 9. You need to type it exactly how you write it. 9, in parentheses, minus 3, plus 2, parentheses, 9, minus 4, enter. What's our output? 20. Okay? So the big idea is for the functions, all you are doing is plugging in the number in the parentheses is your x, and f of x is the same thing as y. Okay, let's try a couple more on the back. You ready?
Is that a function?
Do what? Is what a function?
The last one.
Yes, they should all be functions. Anytime they use this f of x or g of x or whatever, that means it has to be a function if you're using that. That's why it's called function notation. All right, We're going to do the example side. Y'all are going to try these, and then we're going to delta math it. Put a star on this first example with a graph, because you're going to see this on delta math. You're going to see it on your test, and you're going to see it right now. Okay, this one we don't even have to really go to our calculator. We're just looking at the graph, okay? F of 0. So let's say this line right here, this line is, we're going to call it f of x. So make sure you label it so you know what we're talking about. Okay, f of 0. That means I'm looking at when my x value is 0. And my answer is going to be the corresponding y value. So look at your graph. When x is 0, what y value is my graph at? 1. So f of 0 equals 1. F of 3. That's the input. So go to when x is 3. If you are confused on points, I need you to watch what I'm doing right here. I'm starting at the origin. When I go, the x is which one? This way or this way? X is this way. So if I want to go to positive 3, I'm going to go which way?
Right.
1, 2, 3. Okay, so this is what I'm talking about. Now I need to count what y value this point is at. So which way did I go?
3 up.
1, 2, 3 up. So that means the corresponding y value is 3. I think this is easier than the equations, yes. Okay, what about f of negative 6? Which way are you going to go from the origin? Left, how many?
6.
1, 2, 3, 4, 5, 6. What y value corresponds there? I'm going to put a point on there because there's not one. 1, 2, I went down 3. So what does that mean my y value is?
3.
Negative 3. Okay, try this one. One on the right. Try this. We're almost done. Yeah. I've seen questions like this on Delta Math because some of y'all were kind of looking ahead. And they gave you some graphs that were not straight lines, but it doesn't matter. If it's a straight line or a curvy line or multiple little pieces, you're just looking at an X, finding a Y. This is really good to help you start practicing plotting points because that was something last year we struggled with. And do y'all see how I'm writing underneath each of these parentheses that it's an X? If that helps you, I'm looking at this X and I'm finding the matching Y. Write that out so you know what you're looking at.
This one's not going to return a line. I feel like a half, quarter.
This one is what?
The number 3 at the bottom right. Or top, you know what I mean.
Oh.
Number, yeah.
We put 0.5 for that.
Okay.
Yeah, because it's not super pretty. All right, what's f of 0?
3. 1 is the next one.
What? F of 0 is 3. You went up 3.
Yeah.
Okay. F of 5, Braden, what'd you get for f of 5?
F of negative 1.
Negative 1. Okay, why is this a negative 1 right here?
Because it goes down.
1, 2, 3, 4, 5. It goes down 1, so it has to be a negative 1. These are your answers. I'm going to circle the answers. 3, negative 1. Cruz, did you do f of 3? 0.5. So I go right 1, 2, 3. Go up. We can say this is about 0.5. I feel like on Delta Math in your tests, I would give you ones that are like pretty numbers, but we have to guesstimate. That's okay. Why are you saying, huh? Did you go to the right point? Make sure you go to positive 3 on your X. It's not like a perfect, like whole number 1 on there.
This is saying X is 0. X is 0 right here.
Okay, let's complete the table right here. I'm going to let you guys use our little calculator trick for this one because we're finding multiple things here. So let's put f of x equals 3x plus 8. Put in y equals. Okay? Zane asked why we can't do this every time. I'm going to let you do it this time. Okay? So f of x equals 3x minus 8. What are we going to? What is f of x the same thing as? Y equals. Okay? So I still have that old function. Do y'all know how to clear that out?
Yeah, just press clear.
Just press clear. Okay? These calculator skills are going to be helpful. And we're going to type now 3x minus 8.
Second graph.
Press clear.
And we're going to fill in the table. So we're going to put
3x minus
put the equation in y equals, and we're going to press second graph. I'm writing these steps to see the table.
I did it.
Okay?
Press the 2 button. Minus 8.
Are you there?
Okay, I want the table.
We're finding the rest of the table. Second graph.
See where it is.
Okay? So they already filled in 0, negative 8. They already filled in 2, negative 2. What's our next input that we're looking for? 5. So I'm going to scroll. And what output goes with it? 7. What's the next input?
7.
What output goes with that?
13.
Our next input is,
10.
output is
22.
22. So if it asks you to fill out a table 1000%, you could do this. And you can write what you're doing. I put it in y equals, and I went to see the table. Go ahead and try this table right here. I put the equation in.
Right here. Put the equation in, right?
Careful with this. This is a negative at the front.
Table.
That's a negative at the front. Try to fill in this table. I'm kidding. When I say that y equals and going to the table is going to be like your best friend on the STAR test, like I'm not joking. Okay, this is the greatest thing of all time, in my opinion. Algebra 1 style. X plus 2 minus 1. Now you got to know to type it right, and I've kind of said this. The only time, look, give me your eyes. Give me your eyes. Head up. The only time you can put an X in your calculator is when you are in this y equals screen. If you're in y equals, you have to have an X in there. Otherwise, the table is not going to work. You have to put the function, the original equation. So all you have to do is type this in, and then when you go to second graph, because of that X, it's going to give you all these options of different inputs. Now, like I said, it usually starts at 0. The first input it asks for is a negative 3. What do? Use your arrows and scroll up. Okay, go find whatever input you're looking for. So, negative 3, what's the output with that? 0. 0. Input, what's the output? Negative 3. 4. Negative 7. Is that easy to do?
Yes.
Yep.
Okay? All right, let's skip this one and let's go this one right here. We're going to do this one by hand. This is important. Put a star by it. Okay? This is a different type of function than we have seen. Let's graph it. Let's go to y equals. It says g of x. That's the same thing as y. All right, hang with me. What's different about this equation?
It's weird.
It's weird.
Oh, it's got a 2 above the X.
Okay.
What do we call that?
Parentheses.
Power of
Squared.
Power of 2, aka
Exponent.
squared. Exponent. Good vocabulary. Okay, it has an exponent of 2. I just want to show you how to type that. So I'm just going to keep following. I'm in y equals. Are we in y equals? 3. Press your X, which is right by alpha. We know that. Okay, look right here. Look at what I'm pointing to. It's diagonal to the left from the 7. Do you see how that button has an X squared?
Yeah.
Do y'all see that? Press that button. What happens?
It gave me an X negative 1.
Okay, you press the.
You press the wrong button.
Oh.
You press the one right above it.
Wait.
Right here.
Top plot?
What?
See,
I
that's
can't
how
see
you
it.
square
It's just to the diagonal of the 7.
It's right
It
above
says
the line.
X squared.
It's the square
It's right
root.
above the
Yeah.
line.
Wait, I gotta type everything out.
Plus 4x minus 7. Okay, put that in. I just want you to look at the graph because it's
Oh, I
different.
gotta turn it off. That's how you
It makes a
Square.
line.
Hmm?
Oh, it curves.
You shouldn't make a line.
It's the
No,
above- it's
press
above the
graph.
line. See how it says
Press
square?
graph.
Not like second graph.
Then what do we do?
Just graph for right now.
Zane, how did you make it curve? It's just
No.
Let me see.
I typed it in and it just kind of like
Good.
You accidentally paused
And
it.
then we
Here
want
you
the
go.
graph.
If you hit enter too many times, it'll pause the graph.
oh, okay.
It's
Yeah.
still a function.
It is still a function. How do you know it's still a function?
The
Cross over
pencil.
twice.
Whoa,
Because it passes the
X. I don't know. I did it wrong.
Vertical line test.
Wait,
Use
is
it
this like a new concept? Because like before y'all, the calculators didn't have these little things going. So y'all can do it before.
Well, we just haven't looked at a graph before. But this type of graph, this is what we're going to spend, honestly, most of our time is going to be second semester with these types of graphs. But I just want you to see that these are not lines. These are not linear functions. But as Zane pointed out, these are still functions. Because do they pass the vertical line test? Yes. Okay. When it comes to evaluating these, we can go to our table and do the same thing that we did above. But how you're going to see this on the test, I'm going to want you to show your work. So I just wanted you to kind of look at this equation here. Keep it in y equals so that way we can check our work in the table. But go ahead with me and go to second mode. Second mode is always going to take you out of a table, a graph, second mode. They're right next to each other. Boom, boom. Okay? Let's write what we're typing here. G of 0. Where are we going to put the 0 for?
X's.
For the x's. How many x's do we have?
2.
2. But the first one has a
2.
squared. Okay, so we have to write it out the same way. So 3, I'm putting in an x. So what am I putting the 0 inside of?
Parentheses.
Parentheses.
Wait, what?
Squared goes on the outside. This is really important that you put the squared on the outside. So write what I just did, because I want you to write before you type. This is how you're going to get full credit on your test, and you have an equation like this on your test
When's the test?
in a few weeks. I don't know the day. It's on Canvas.
Week from Friday.
September 9th.
I thought it was like next week.
It's a week from Friday.
I think it's the end of next week, actually.
Week from
What?
Yeah. Today's Tuesday. Today's Tuesday. You're good. You're good.
week and a half.
We're going to be fine.
Isn't next week
Okay.
like 3 days long? 4 days?
4. All right, here we go. 3, I'm typing, parentheses, 0. You can still use that squared button right here to get your exponent of 2. But the key with this is the squared's got to be on the outside. Has to. And you've got delta math like this, so
What'd you get as your answers?
I go to the bathroom.
we're almost done. We're almost done.
Just do it here.
Do I have to graph it?
No, just put it in, type it in, regular calculator screen. Regular calculator screen. This g of negative 2, you guys, we're doing the exact same thing. Negative 2 is going in the parentheses. It is a negative. Here's what's so important about this is the squared is going on the outside. And if you don't put the squared in the right place, you are going to get this answer incorrect. How can you check your answers? Make sure you did them right. Y equals. You've already got the equation in there. Go to second graph. But I do want you to show me your work here. Do y'all know how to copy and paste in the calculator? Okay. Let me show you that. That's kind of cool. Copy and paste. Yes, you can. All right. So do y'all calculators still say this?
Control C.
No, hold on.
No, it's not Control C.
There we go.
Control V.
Go do your up arrow. I think it'll be there. Okay? Yeah, there it is. Okay, so if you wanted to copy, let's say you accidentally typed a 1 and you meant to type a 0. Okay?
COS.
Up arrow. No. It's way easier than that. Take your arrow and go up 1 time. What happens to the last answer that you got? What is it now shaded in? Blue. It's kind of hard to see on my screen, but it should be blue. Does your negative 7 have blue on it?
Yes.
Okay, go up 1 more. And now you have blue on the whole expression. That is copy. Blue is copy. Press enter. Paste it down. And then you can just scroll around left and right and replace. I'm afraid the negatives might mess. Why are you putting your calculator up?
Yeah, the negative messes up.
Okay.
It does.
It does. Dang it.
Yeah, it messes up.
Dang it. Well,
Better if it was a positive.
that would be a lot better if it was positive.
But, so I want to put a -2 in it's receiver. So come here and let's put -2.
I'm almost done. All right, let's do this one word problem together. Okay, page 6. Even though there's word problems, it's still the same stuff we've been doing, people, so don't stress. This is kind of star-like. So what's our story? What are we trying to do?
Purchase
Some pencils. It sounds like my life. Purchasing pencils from Amazon. Okay, each box costs $3.75. There's a shipping fee of $5. This person doesn't have Amazon Prime.
Should be.
It can be represented by the function f of x equals 375x plus 5. How'd they get that?
Because they use the cross, they used each box that cost $3.75 and added that to the shipping fee.
Okay, so you see how it says each box. Each box is $3.75. So when we write that, or a lot of times it will say per, $3.75 per box, that means you have to put a variable by your $3.75. Because however many boxes you have to add in that $3.75 per box. The shipping fee is only done how many times? One time. So there's no variable by 5. So that's how they built that equation. $3.75 per box plus there's your shipping fee, one-time fee. Okay? What does X represent in this story? 375X. What does X mean? The number of boxes of pencils. Number of boxes of pencils. And then f of x is going to represent our money. Our money. How much money we spent. What's the total cost for 7 boxes? What do you do?
35. I just guessed.
You just guess? Well, what do you do? You're going to find 7 boxes. What is boxes? 7 is your x. So you're going to put 7 in for x. So you're going to evaluate the price for 7 boxes. 3.75 times 7 plus 5. Plug in your calculator. Find out how much I'm spending on pencils. $3.75 times 7. You don't type that in your calculator.
It's right here. So we're saying whatever, 7 boxes, so we throw 7 in here. So the 7 in for X.
What'd you get? 31.25?
I got
So we'll-
31.25.
7 boxes. Yes.
I didn't do it on the main. I did it in the y equals.
It's fine. Just be able to explain what you did.
Yeah, it's like and the y equals and that right over here.
So you can find out how many, 1 box, 2 box, 2 box. Okay, try this word problem when you're done. Delta Math, you have 5 questions on this section. I don't think there's word problems on there, but you'll see it's this little 2.1 evaluate. There are 5 questions that you have to get right. Some of them are graphs, some of them are equations. And then this is not on Canvas, but I will add it on Canvas. You have a CFU on this lesson next class. It's not a real grade, it's just a practice. Practice run, see what we're doing, how we're retaining, and then we'll learn new stuff. Okay? Ready, set, go.